Okay. Things are looking pretty good here. I'm recording. Should be live. I see myself, so I guess that means I'm live. Hopefully I can be heard. According to OBS, my mic should be rolling. All right. So welcome, ladies and gentlemen. A little bit of a different stream today. Normally I'm working on my web-based game with the working title Trace Racer. But today doing something a little different. I've been kind of learning C/C++ programming language. And I've been kind of doing little mini projects on the side. So I had one that I thought was kind of interesting. And I decided to, well, I've been thinking about it for a while. And yesterday I did some work, not on stream, trying to, so I actually have something, so I'm not just starting a new project from scratch here. But I've got it built up to a point, but I need to clean some stuff up. And that's what I decided to just stream working on. So what am I working on? Well, this is a Skybox maker for like 3D games. So I kind of thought, I remember one time not really understanding how cube maps or skyboxes work in games. So I originally thought like, oh, you could just slap a texture on a cube and things would just render correctly, like just some texture, and throw it on a cube and it would work. But that's not really exactly how it works, because there's a lot of stuff to deal with because what you're doing is you've got a sphere. You want your square cube actually to look like a sphere from the inside, if that makes sense. So what I have so far, I'm previewing everything in a web browser. So this is just a little web project for 3D. I'm using 3JS just to preview my Skybox creator. So what I'm generating are the images on the outsides here. So, well, in my Skybox cubemap endeavors, I realized, oh yeah, you can't just slap a texture and then it'll look like you're inside of that texture or whatever. You can't just slap a texture on the inside of a cube and you're done. So the cube has to be properly projected as if it were inside of a sphere. So what I've done so far is actually, I think I've got it working. Right now, clearly I have some issues with the ordering and everything, which texture's supposed to be where. But I decided before I really dig into that, because I kind of jumped in. I jumped into this, just said, all right, I'm just going to program and go. Like I wrote down some notes and came up with what I thought I should be doing. But then I started to run into issues with the ordering and the sides. And I was also running into an issue where my pixels are rendering upside down because the y-axis is flipped. So I thought, all right, I'm just going to stop trying to push this forward and try to do it a little more correct. Because kind of my goal with this actually is I'd like to make a YouTube video kind of tutorial, not so much a tutorial, but just kind of like, hey, here's something I did out of it. I'd like to make a video out of this. So it's got to be a little more standardized and kind of work for everyone. So like I was saying before, what you're seeing here is not, I'm not building a 3D renderer at all. What I'm building is just simply a little program that's just going to generate the sides of a cube, the 6 sides we need for our Skybox cube map. So I've got Wikipedia. Oh, it's in a new tab here. Got Wikipedia kind of explaining this. So we've got, our 6 images that need to be all wrapped around the cube. And I had it kind of working very generically. I mean, what you see here, obviously nothing's lining up. But I found this nice little image here that I think helps clear things up, or at least standardizes things a little more for me, which is good. So I can kind of go off of this to help guide me into the correct way. There's some actual like C examples here for, yeah, memory addressing, whatever. I don't really need to do anything with that because this looks like it's for like UV texture coordinates, but I'm not building this in a 3D engine. I'm just building something to export the images out. So basically what I was doing a little bit right before I started streaming, I was just kind of cleaning stuff up because I've got a lot of errors, and I was kind of cleaning up the code because, like I was saying before, I'd like to be able to turn this into like a YouTube tutorial. So this first part here is going to be a little boring. I say tutorial. It's not a YouTube. It won't be a tutorial. Tutorial implies I know what I'm doing. But that's kind of the thing, is I don't know what I'm doing. So it can't really be a tutorial. So I'm going to clean up some stuff. Just try to get more of what I have working, and then I might do a little more of a proper talking about what the program's actually doing, because it's actually fairly simple. Like the amount of code that's going on here. I mean, I've got my int main function, and that's pretty much it. And what it does, as of right now, it only generates one side at a time of our cube map. So we have to specify which, right now in the code, specify which side we're going to do. And like here, I've got kind of the positions of all the sides that we need to render, which I now need to change all of these because I'm realizing the ordering's wrong and my pixels are rendering upside down. So, but all in all, it's pretty simple process. I mean, here's the meat and potatoes, where basically I'm taking my coordinates of where my plane should be in 3D space. So like one side of the cube where that should be in 3D space. And then I'm looping along that where all the pixels should be. And then we're kind of mapping those to a cube to say, okay, here's where the pixel actually should be, or mapping them to like a sphere to say, okay, we should actually be here. We're here on the side of a cube, but we want to be here because we're inside of a sphere inside of a cube. I'll talk a little more about that later. I'd like to just clean this up and get it working because I was kind of changing some files around and everything, and yeah, stuff's just kind of a mess right now. And I'm also using, I won't talk too much about it, but I'm also using a BMP file. I'm writing everything to BMP files. So we've got, I wrote just a little header file here to convert bitmap, to do the bitmap file header and then actually write a bitmap to disk. Kind of simple. It's just doing like the bare bones, writing raw pixels to the file. So no compression or anything fancy. And yeah, I'm not really going to talk about that too much on the stream. But yes, so currently we're not compiling. Am I zoomed in enough here? There we go. Error C, initializing cannot convert from initializer list to vec3. It's in main CPP 13. Oh, yes. So I was changing some stuff around here. Vec3. What did we have? Float x, float y. Oh, wait a minute. actually. Let's change that. So I deleted some stuff, changed some stuff. So yeah, one of the things I have here that's obviously a critical component of this all is this struct vect3, which is representing 3D point in space. So that's where all of our pixels, we're representing all the pixels that we would need to draw the image in 3D space. So we use that, and we do some vector math to kind of manipulate those and move them around to where we need them to be. So I've got some functions here that add two vect3s together, subtract vect3s from each other, scale vect3s, multiply a vect3 times some sort of value multiplier, scalar. And then also a distance. I have a distance function here that calculates the distance between two 3D points in space. So nothing too crazy. All right. Oh, and also I have an image file here to represent what an image would be, represent what a pixel would be. I have a pixel struct that is BGR, pixels laid out in BGR format. I think I did that for the bitmap, to write to the bitmap files a little better. But I might end up changing that to be the RGB layout because that's a little more standard. But basically 8-bit, 1 byte for blue, green, and red pixels, and then an image, which is another struct here that has a width, a height, and a pointer to our first pixel. So then we'd have our full pixel array of all those pixels. Pixel pointer, pixel array, I don't know. I'm kind of new to C++. I'm kind of learning, so go easy on me. Yes, so I should have just fixed that. Let's see if we're actually building now. Vect3, no appropriate default constructor available. 65. Vect3. Yeah, I don't know if I want to actually have these constructors at all, because it's just kind of more x equals y equals z equals 0. Oh, 0.0f. Okay, we're building now. What are these? Oh. All right, so it's running. Code is running at least now. Yeah, actually, I can just change this to that now. Building, fine, and let's actually run the file here. Nice, okay. So we are generating one file here. I don't remember what I had plugged in to actually generate this, but I'd like to go and kind of more properly figure out what I'm doing. Well, now I could use this as a time to talk about actually what we're doing here. So as it stands right now, I'm just generating one side of our Skybox cube map. I did that initially just to say, okay, you know, I don't want, and I'm going to continue doing that right now just to make it simpler. I'm just going to generate one side of the cube map just to see if I get it and make sure everything's correct on it. So one image of our skybox texture. And basically it just starts with, we set up our image, which is where all our pixels are going to be. We allocate enough pixels, which we just do by, multiplying our sides, our width and our height of our image together, times 3, because we're doing 24-bit pixels. And then this vec3 here is just 0, 0, 0. Yeah, I just use that as kind of like a constant to say the origin of our of whatever we're doing. What I have here is, I just call this front. So this is just an array of 4 vectors that represent just the, shouldn't pixel hold how large it is? Yes, I don't necessarily need that right now. I mean, yes, I agree. It should be like a pixel 24 or a pixel 32 or something like that to represent how many bits we're using for that. I don't really care too much about that right now. But yeah, it would be nice to, I think I understand what you're saying there, like size of pixel or something instead of 3. Oh, I see what you're saying. How complex is your Skybox? Right now, not very complex. So basically this project, well, I don't know if you heard how much you heard earlier, but I'm kind of learning C and C++. Is it blue? Right now I am doing, so everything's wrong here. This is a wrong example, but these are the images I'm generating. So I'm just making sure that I'm correctly doing perspective mapping of a sphere onto the cube. So for the visualization, I'm using a little web project here. This is just it's using a 3JS, which is a JavaScript library for doing WebGL and whatever in the browser. So I already had a project set up from that a long time ago, and I just grabbed it yesterday to throw it in as a visualizer here. So we could have just, is it able to paint your bitmap onto something? Yeah, there's like there's a scene object in 3JS, and then you basically just load in your environment map, and then you just throw that onto the scene as a background, I think. Very, very simple. I mean, to do all of this is pretty basic. My own code to actually set this up was very simple. I basically I have this cube in here for reference, this wireframe cube. But otherwise, yeah, there's not too much to do. They've got all the stuff set up for it's a separate like little library they have, but you can, to do these like orbit controls, they call it. So, yeah, pretty basic. Yeah, so so I see what you're saying now. You were saying size of pixel instead of 3. Yeah, I guess that makes more sense because I guess I misunderstood what you were saying before. Size of pixel. Yeah, cool. We'll do that. So, yeah, exactly. Yeah, less magic numbers, correct. So, as of right now, I'm just generating one face at a time. So that's something we need to clear up. But I think before we even do that, I need to make sure that I'm doing the faces correctly. Because originally I just said that I was using a left. Was I doing a left-handed coordinate system or right? Let's see. Z top X. I'm bad with left and rights. Okay, so yeah, basically, is this something to do some generated vector art or load some pre-made image to project somehow? This is just me kind of having fun. I wanted to make sure that I understood. Well, eventually I'd like to do kind of like a little ray tracer, just very basic ray tracer, just in kind of learning 3D graphics and everything. So this is kind of a little first step for me, I guess. Basically just I wanted to solve that problem because I remember at one point in time when I was doing some 3D stuff, I remember just throwing like a flat image onto a cubemap Skybox, right? And then being like, oh, that must just be, you know, like the curved spherical part of it must just work, right? Like that must just happen when you put a tech, you know, that's part of the renderer or something, right? Well, no, that's not how it works. Because if you just throw some random texture on the side of a cube and then another texture here, even if they're seamless, it just looks like you're in this giant cube, right? Kind of like it does right here, you know, it just looks like we're in some infinite giant cube, right? So I wanted to, basically I wanted to solve that problem, like prove to myself that I could solve that problem. So, so far I have, I just need to, right now, I'm just going back and cleaning up, map an image onto the top half of a sphere. No, like, well, yeah, let me clarify a little more here. So let's just take like a top-down, oh, wrong tool there. Pencil, paintbrush. Okay. So, you know, like let's just look at the corner of a cube map here. Like we're doing a top-down view, let's just say, right? So if you just slap, you know, our viewpoint of the character, player, whatever, camera is right here. So whatever, you know, if we just throw some random texture onto the wall, it's going to be, you know, dead center here, which I'm doing length of 1 for this. So that would be length of 1. You know, I'll just do this in 2D. Oops. I'm still getting used to my pen here. All right, so then we've got, you know, at this point here, we've got -1. Well, we'll do -1, -1. Right? So the problem is, like, you know, you want this to be, you want any point of your background skybox to look equidistant from the player, right? But if you just slap a regular texture on here, well, the distance from here to here is 1, but the distance from here to here, you know, is square root of 2, 1.4, whatever, something. So you lose that. You don't have that perspective anymore. So the idea is I'm just So the top half of a sphere or approximated sphere will all be the same distance away from the player. Exactly. So instead of basically what I want to do, so, and what this is doing right now, I'll just show this here. So like if we just look at here's all the individual files. There's some other files in here, whatever. But actually this thing's a complete mess. I need to clean that up as well. But this is our generated images from all those different sides, right? And if you can tell, we're kind of getting like, look, there's like some curve happening there on like that red, like it's kind of round. So that's good, you know. So this one should all be like, if it's mapped correctly, this one should all be seamless and look good. But what I'm doing for this is basically just saying like a certain point in space is a certain color value, like a certain Z, if Z equals 1. I was recently watching a dude's YouTube video where he wanted to make some randomly generated planets. In the beginning of the story, he was talking about many different ways to efficiently create approximated triangles to represent a sphere. Nice. Yeah, in this case, I'm doing something just very simple. That is interesting. I mean, in this case, I'm just doing something super basic, where it's all I'm doing is saying. So let's just say this. So what? Well, I'm just doing like a 2D representation here, but let's just say -1, 0 here. So at this point here, let's just say it's supposed to be blue. So like what I'm doing is, as you get like, so whatever point we are taking for our pixels, for our images, however, well, okay, so I'll say how I'm transforming it here. I'm looping along the image, the side of the cube, right? Just the 2D, we're looping over each pixel, but each pixel is in 3D space. And then what I'm simply doing is moving it to the side of the sphere instead, right? So like if I'm looking at pixel 0 of this image, this flat image, right? We're looking top down of the image at the side of it. So, or the top side of it. So this pixel is the square root of 2 away, 1.4 something long, right? But we don't want it to be 1.4 something away from the camera. We don't want it to look like that. We need it to look like it's 1 away, right? So all I'm doing here is just taking the distance of this pixel from the center, and then taking our distance of 1 and just taking the 1 over that distance, and then scaling this pixel vector back, the position of that pixel in space, scaling it back to where it would be correctly positioned along the sphere. And then what I'm doing is currently I'm just saying like, whatever the position of your pixel is, like make it blue if it's -1. So if our X position is -1, it's 100% blue. And then anything else, it's, some sort of gradient along that, like slightly less percentage blue, right? So instead of this pixel will then get rendered, instead of being 100% blue, it would show up as 100% blue because the X value of that pixel is -1. So if our pixel was here, it'd be 100% blue. If it's here, then it would be slightly less blue, right? So like according to this, it would be, whatever this distance is. So we take the new X value of this, let's just say it's 0.333, right? Because it looks kind of like it's 1/3. And then that would be, 25% less blue or whatever, 33% less blue, whatever. Isn't that part of the rendering engine then? I mean, if you were doing this like dynamically in 3D, yes. I am just generating static images, and like maybe the way you would do, maybe like skyboxes are done like super dynamically and really cool nowadays. So maybe what I'm doing is like from 1999, but nonetheless, I'm just using this as like an experience, or as an experiment to just kind of make sure I understand what I'm doing a little bit with 3D kind of stuff. So yeah, so basically just kind of taking a pixel value and mapping it to where it should be spherically in here and kind of figuring out that sort of thing. Good luck. Thanks. My kind of goal after, because this is pretty basic, like right now, -1x is just, we're saying like -1x is blue. So like you take your percentage, whatever, to change that color, whatever. But what I'd like to do is kind of maybe have like colors that are points in space, and then they have like a sphere or something around them, and then maybe depending on how much, they have like an attenuation thing across their radius or something, and then maybe depending on how, kind of like maybe like a point light or something in a 3D engine, and then kind of taking like the distance from that, and then some sort of whatever averages to kind of figure out all the colors. So basically just trying to kind of come up with something cool and, see where it leads me. But the main thing is really just making sure that I understood that I was doing this perspective kind of mapping somewhat correctly, which I think I am. Because when I did have some examples working correctly, when I was working on this yesterday, stuff worked. Like it was seamless. It didn't look like you were in a cube anymore. So from that end, I think stuff was looking pretty good. So how far I'll take this, I don't really know. But yeah. So anyway, move this out of here. So I think we are good. Well, I ran the program before, and we were correctly compiling, correctly building. So let's look at Wikipedia again. I wish they had these up, left, back, front, right, down. I wish they had that on this image. There we go, a little bigger there. There. So let's refresh this. Nice. So what I incorrectly assumed right away is when I did this without even like looking. I did this face as being the front face. And this face, I believe, was Y. I was doing Y plus Y. So what I should be doing is left. So that's the left face, and that's plus Z. Z I was doing on top and bottom. So that's a problem. Like I did plus Z as being the top image, and minus Z as being the bottom image, bottom face. So that's already an incorrect thing I was doing if I'm doing this the standard way, which I would like to. I'd like to at least have this maybe somewhat standard, like these indexes and everything. Face 0, 1, 2, 3, 4, 5. I'd like that to be all capiche. So, okay, so I also need to Yeah, plus Z. So this is a left-handed coordinate system, right? Because we're doing Y, X, and then Z. Y, X, and Z is going out that way. If I know what I'm doing here. Except it's backwards. I don't know. Maybe not on the camera. No, it's not. It's be left-handed, right? Oop. Y increasing X increasing Z. Right? Yes. So that face is considered our left face. Let me make sure I was drawing this correctly here. So I was... Maybe I should just have my little visual aid, which is scribbling on a piece of paper. Yeah, let's... Maybe I'll throw this in GIMP here. First, I'm going to hit the bathroom real quick. So be right back. Don't go anywhere. Oh, yeah, I can zoom in, control scroll. There we go. All right. All right, I'm back. Okay. So, this is what I thought would be my new front face. Let's pull this up here. Can you see that and that there? No, maybe not. Let's do... Yeah, I'm going to need a little visual aid here. So we're doing a left-handed coordinate system. So I am doing whoops. So we've got Y, X, and then Z is going this direction. All right, that's left-handed, yes. So actually, I might need do a new one here. Oops, there we go. Okay. There we go. All right, so we've got a Y increasing. This, oops. Get out my pen here again. Paintbrush, whatever. So we've got Y increasing. Oh. So we've got Y increasing, Z increasing, Z plus, X plus, right? So that would mean we have this direction. What a pain here. New layer. Merge down. Will that do it? Yes. Okay. All right. So we've got Z minus Y minus X minus. So according to here, we've got at Z plus, that is our left-sided face. So that is, it's face 4. That is first face. So we would have left oops. Left. So that would mean this is right. And front was face 0. At X plus, yes. So here we've got front. And that would be, make this back. And then that would give us up here top and bottom. All right, so let's just look at the left side, the left hand face then. So the one thing I need to do, one mistake I made was I was doing the pixel coordinates, because the image file starts the pixel coordinates in the top left, right? Or that's just how, you know, typically anything computer-wise, you consider that pixel 0, 0, 0x, 0y as the top left corner, right? So y increases, the y-axis increases as you go down. So that was another thing I didn't factor in, because basically all of my images, when I was first generating them, were all inverted, were all upside down, right? Inverted along the x-axis. So that's a problem. So we need to start with the correct position with the y at the bottom in our 3D space. And then that way, when we actually draw them, write them to the file, they will write in the correct, they won't be upside down anymore. So the coordinates then, so basically the way this is working, we've got our origin 0, 0, 0, right? 0, 0, 0. And then the size of our cube is it's a 2 by 2 by 2 unit cube. So that means with our origin at 0, 0, 0, so that means we're dealing with everything that's either -1 or +1. So somewhere in between that, in that space. So our left hand image here, I'm going to make, what I'm doing is specifying the points of our left hand. So we'll say this is left. And we need to, I'm going to have the points that are structs in order. You can see I've already kind of have this in this case, right? So I have 3, oh, I said structs, I meant vec3s. So I have 4 points in 3D space that represent our plane, our one image, right? It just represents the 4 corners of that image. And the order they are right now is this first one is top left, and then it goes top right, and then bottom right, and then bottom left. So it's like drawing the, this looks backwards, I guess, but it's like drawing around the, yeah, there, I did it right. Each point is like in that order, right? So what I'm going to do is do it backwards. Now 0, the first point is going to be the bottom left corner. Yeah. So we just need to flip the y-axis. So the bottom left corner, and then I will do that, but in reverse now. So starting from the bottom left to the bottom right, and then around. So we're going to start with this point first. So this point, if we are aligned on the z-axis here, so our first point is going to be -1x, because our first point will be down here. So we're on the z-axis, but our image is like down here. So I'm doing this, trying to do this in 3D, but trying to explain this in 3D, but with 2D, obviously. So our bottom point is going to be, the dead center here is 0, 0, 1, right? Because we are positive on the z-axis, so this is 1. So we need to have, this would just be -1, -1, and then 1, right? So that is our first point. Screw that, I'm not going to do the parentheses. All right, and then our second point would then be the one that we're going to go along this way, right? So first point, second point, third point, fourth point. So then this one is just positive x. We just slid along the x-axis here. So we're still negative 1y. And we are positive 1z. And then here we're going up to 1, 1, 1, 1, 1. And then here we are going back to our negative x. Right? Yes, I think I got that right. So this needs to be the order of our points in space. And we are making that the left. This will then be the left side face. So let's, and I think I started to do this yesterday. Oh, maybe I started with the front. So we'll call this left. Right now I just have this vec3 array called front, but I need to change that and everything, but we'll get to that. So this is our point 0, 1, 2, 3. So point 0, 1, 2, and 3, right? So we're going to be negative 1, negative 1, and 1. Whoops. I already have 1 for all of these. Okay, so then we are, that was our point 0, so now we are 1, negative 1, 1. That one's already correct. Then we are 1, 1, 1. And then we are negative 1, 1, 1. Let's line these up kind of nicely. Okay. So this should be our left-hand side plane. So what I want to do, Retro MMO, hi, how's it going? Hey, thanks for the raid the other day, by the way. I saw you did that, but it didn't pop up on my thing. I don't know if that was some setting you had or something that didn't show me that you were raiding. Okay, so this should be correct for our left-hand side face. So to test that, let's do, I think it's because I rated after a rerun. Doesn't pop up like normal. Gotcha. What's a rerun? Oh yeah, thanks anyway. Yeah, because I've been trying to be better at reading the feed and everything in OBS, but I don't always. And sometimes my speakers turn off out here because if no sound plays, my speakers will auto mute themselves. In Twitch, you can air reruns of previous streams. Gotcha. Oh, okay. Oh, nice. I gotcha. Cool. Okay. Yeah, so to test this, I want to say the colorize, the picking of the colors for every image, or for every colors that are used in the generation of these is pretty simple right now. I'd like to make it a little more sophisticated. But basically, I need to figure out, let's look at our GIMP diagram here. Okay, so we've got our left-hand side image. So let's make something, let's make X plus be blue. So that, actually, let's do it from the bottom. So that way we can tell if we rendered it correctly upside down or not, or if I fix that now. So we've got, let's do it from the top. So we'll make blue be Y. So the closer a pixel in 3D space is up to the Y-axis, the more blue it will be. And then, yeah, let's just do that, and we will make sure, well, that'll at least tell us if we are correctly. Just doing that would make left, front, right, and back sides of our skybox all be identical. So we need to do something to also prove that this is left. So let's make, well, first let's just make sure I'm doing the order correct now. So we'll do blue at, what did I say? Y? Yeah, on top. So we'll make, I'll just cover this here. Yeah, what was I doing before for these? If pix z, well, we'll do if pix y is greater than or equal to 0. Retro, what sort of progress have you been making on this lately? I'm actually taking I'm not doing a stream. Well, I might do it later, but I'm not working on my game currently. I'm working on a Skybox maker in C. So yeah, this is just kind of like a little side quest thing. Yeah, no worries, no worries. That's not valid C. I see a constructor. Yeah, sorry, not 100% C, but some C++ as well. I'm trying to do as much C as I can, not do too much C++, but I'm learning. I'm figuring it out. Oh, what am I doing here? Yes, so basically we want to take our pixel x value and then I can kind of copy what I have here before. So we've got, yeah, I guess we will take just this line here. If pix x we're doing is greater than or equal to 0, then we will do b equals this line. So let me just make sure that I'm doing this right. So we're taking our x value. Yeah, and only in the case where it's greater than 0. Okay, so we're somewhere between 0 and 1. Taking that, multiplying it by 255, rounding it, putting it in an unsigned car, and then we're done. And all these should be yes. If you're learning C++, a good habit to get onto early is to namespace all your symbols. You will not have fun when you finally hit the right kind of ODR violation. Namespace all your symbols. I'm not exactly sure what you're talking about. Like all of my stuff, pixel, all that sort of thing. All of my types and structs and that sort of thing is what you're talking about. Oops. All right, so let's try this. Oh. Now. Yes, actually, because we're doing BGR. I need to flip that around instead of RGB. And put anything used only within one CPP file into an anonymous namespace. Oops. There we go. All right, this isn't right. This is sideways. The blue should be on the top, according to my calculations. Untello, and put anything used only within one CPP file into an anonymous namespace. Gotcha. Yeah, I mean, I haven't been doing anything with namespace. Because I've been mostly doing C. I mean, like you said, yeah, I have a constructor, whatever. I mean, since this is just very tiny, I might clean it up, whatever. But I'd like to try to keep everything as C as possible. And I think I will actually get rid of those constructors at some point later. I'm a little confused. Since I'm learning everything right now, it's a little confusing because right now I'm using MSVC and I'm using the CPP extension. So I don't know if there's a switch. From what I could tell with using GCC before, if you used a .c extension, it treated it as C. If you used .cpp, it treated it as C++. Because I think I compiled this with GCC and this was fine. But I've noticed, maybe I'm wrong. I thought I noticed GCC saying if you had like a .c extension, it would break or something. Or you're doing C++ things, but in a file that was .c, it would break. But I don't know. But thanks for the suggestions, Untello. Appreciate it. Yeah, as of right now, we're drawing the file incorrectly here because the blue should be on top. So the blue, did I do the right? Let's just make sure. Oh. No, I did X. It's supposed to be Y, right? Yeah, it's supposed to be Y. Oops. Muscle memory. All right, let's see how we're doing here. There we go. Beautiful. So that is what we want. We said Y. Right, Y plus is on top. That's exactly what we want. Now to make sure we are, okay, so now we know we're doing our Y, we're doing the Y axis thing correctly now. X plus, we do, well, actually, I know that was working too, because we did just try it with X plus and it was on the right side, right? Because we're looking at our left-hand image is facing this direction, right? So Y is up on top here, and X plus, Y plus is up here, X plus is here. Just for kicks, I will do this, literally the same exact thing, except we'll do it with X, and we will do it with red. So that way we kind of have a nice little, whoops, X. Build that bat, main. Beautiful. And we got a nice little red there. Nice little blue. Cool. And yeah, that's kind of the thing is we're getting, because we are doing the mapping stuff onto mapping onto a sphere, so to say. So we have the little bit of curvedness on here from these two. So that's looking pretty good. Untello, if you just do C, name collisions aren't as dangerous. You'll get some compiler linker error, and C++ name collision might cause seemingly random memory corruption. Gotcha. Good to know. Good to know. Okay, so I proved now that this is what we want. now I'm trying to think of what I want to do first. We could do, actually, this is what I was kind of doing before. I was doing, we want to do a Z now. So let's just make this X, Y, and then green will be the Z axis. So if pix Z and green equals unsigned char pix Z 255.0f XYZ red, blue, green. Yeah, I guess that doesn't really matter. Cool. Okay, so that's correctly what the front panel should look like, right? Front. Let's just check this quick. Yes, so Z 100% is full green. So we're getting this full green. Well, not quite full green, but mostly green, and then some blue coming in from the top, and then some red coming in from the left. Right. Is that the left or the right? I don't know. Yes. Okay, so that's what we're seeing. We've got just solid green, right? It's starting to taper off towards the edges. We got some red coming in. That's why we're getting yellow, because red plus green equals yellow. We got some blue coming in from the top, and that's giving us kind of a little cyan color. That's looking good. And then here we're getting some, you know, whatever, white, gray. It looks kind of reddish, though. That's just an optical illusion. It looks kind of reddish. It's interesting. How do you unzoom in this? Okay. Cool. So that's good for our left side face. And we should be doing it standard, at least according to Wikipedia. So that was our face number 4 here. Z plus, according to this, and I'm taking this image and this image as gospel. Left, and the Y order, Y whatever is correct. I'm not rendering it upside down anymore or drawing it upside down. Cool. So I can keep this. Before I try to do something too fancy, we need to preview it. We should preview it in our little web thing here. So obviously everything's wrong in this example. We got all these colors, but none of them are matte. It's obvious we're inside of a giant box, a giant cube right now, right? So none of our edges are lined up. We got all the wrong order. I think the top and the bottom are correct, but they would have been drawing upside down, because now that I've fixed the Y stuff, we're looking pretty good. So I'm just going to do them all one at a time, which is going to be really boring because, well, let me do these in the right order too. So left, and we're going to call that 4. I don't like that minus. So let's do our, this is going to take a little bit here. Our front coordinates, we're at X plus, so what index is the front? That's 0, right? Yes, front should be face 0. X plus. So front is going to be, actually, I'm just going to get rid of, we're going to do this. So we're going to call this front and 0. And now for the coordinates, well, we know X plus X, right? X increasing. So all of our X values are 1 in this case. Could have did multi-cursor there, but I didn't. Too late. All right, so we're going to be sharing. Okay, what did we do? We did 0, 1, 2, 3. So 0 is going to be position 2. Let's do that. I'm just going to do this. All right, so then we are stepping. Okay, x is 0. And what are we doing? Y and negative z. Oh, negative z is going that way. Going back. Right. So we need to do... Okay, so the first point we've got is correct now. And then we are going... Man, I actually need this reference. No, I'm going to screw that. I'm going to do my GIMP one here. Because I can better visualize. This puts me at least into the 3D space in my head, so I can better visualize what I'm talking about. So our bottom point is putting us into negative, what do we say? Negative y. Y is negative 1, and z is positive, right? Let's pull this up really small. All right, so y is negative 1, z is positive. Then we are going underneath to z is negative. We have the same y position, but now z is negative. And then we are going up. So y is positive now. That's what we got here already. And then z is still negative. And then we're going... Wait, did I just do it backwards? Negative z, negative y. No, I did it right. We're going up. So y is positive, z is still negative, and then we're going over. So z is... Yeah, then z is positive and y is positive now. Cool. All right. So that should be all correct. One, negative 1, 1. All right, so if we do the test of this one, it should be full blue. What did we say before? It should be full blue with a little green over here. Green coming in from the right. And red. Oh, I don't remember what we said. Oh, this is red. X plus is red. It should be full red with some green off to the left. And then some blue coming in from the top. Yes. So we're full red. Got some green coming in from the left. Blue coming in from the top. Cool. All right. So... now we need to punch in. Let's go. Okay, we got 0. Then what is next? Front. Face 1 is back. Okay, so we'll do back. All right. So we've got, oops, back 1. Copy and paste this. And then Yeah, we're just doing the riveting, the stuff that makes for a riveting, exciting, inspiring stream right now. I'm trying to remember lefts and rights, and trying to do it in 3D too, right? Making it way worse. All right, so we've got back now. So we're doing the image that's back here, facing this direction. So we're pointing at this text, at this image, right? So when we're starting down in the bottom corner, bottom left corner. So that would give us, or wait, x is negative in all of these, right? Yes, because we're doing the opposite of the front. So x is negative in all these cases. And we are starting with y negative and z negative in that case. -1. That's our 0. Now we're sliding down to the other bottom corner of this image, which would just make our z positive. Then we are sliding up, so our z still stays positive, and our y is now positive. Yes. And then we go back to a negative z, and our y stays positive. Yes. All right, so that was back. So we got front, index 0. We got back, index 1. Now right should be index 2, right? No, actually, I think left and right are 4 and 5, and then top and bottom are 2. Yeah, top. Okay, top is 2. All right, this is going to be fun. Top is 2, and its bottom edge, the bottom edge of the top plane is touching the top edge of the front face. So this is our front face is here, so our top edge is there. So our bottom, right, like our top edge is going to look like this. Yeah, I could do that, right? And it's going to be touching the front face. Right, so that's our front face. If that makes sense, if you can see my 3D here. So our front face, and then our top face. And we need to start the top face in this corner. Go here, here, and then here. So those are the points we were doing. Oops. Ah, what happened there? Okay, so we're starting with this, because this is the bottom of the image. Yes, this is the bottom of the image, so we need to start with the bottom left point of the image. So that would be, okay, so y is positive in every case, so let's just set that up. So we'll do that. We will do, this is now top index of 2. Oh. Index of 2. We are yes. Okay, so then we've got yeah, all the y's are positive in this case. So we'll do that. The x for the first point is negative, and the z is positive. And then so we just did this point. We found this point in 3D space, and then we are sliding here. Yes, because we are looking right now. What you're seeing here is the backside of that image, right? Like this is supposed to be the whole cube, right? More or less, right? So we're supposed to be inside here looking up at the top. So what we see in GIMP is the backside of this upper image. So everything's like backwards, and I'm having to do all this in my head, and I'm not very good at it. But we got our first point. We got it on there. And we know that all the y's are positive, so that helps. So we started here. We're going here now. So x just changes to positive. Z doesn't change. We go here. Now x is the same, but z changes. And then, did I do that right? Yeah, here, here, here. And then we go back here. Here we've got z's negative still, and x is negative. Yes, negative, positive, negative. Cool. So that should be good. And I'm having some errors here because I need to comment all of these out. That's the other thing, because right now I just have my plane, my one image plane, which is just a single array, a length of 4 array for vec3s. So we're storing the 4 points of each image. And it's just called front right now. So we're gonna loop over all these points and do all this cool stuff. Okay. So now top. Wait, we just did top. So now we need to do bottom. And left is already good. We already did left. So we're going to do this again. We're going to do bottom 3, which should be index of 3. So now we are doing the bottom image. The bottom one here. This will be easier because I can actually see. So we're going to start with this point, then go to this point, then this point, then this point. And the bottom image aligns with the top part of the bottom image shares the same edge as the bottom of the left image, right? Yes. Left, down, they share that same edge. Beautiful. So our first point is down here. So all our y's are negative. Negative, 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 negative. And we are starting with negative x, negative z. Negative x, negative z. We're starting here, then we're going here, which would just go positive x. Oops. Yeah. Positive x, negative z still. Then we are going positive z, positive x. Cool. And then we are going negative x, positive z. All right. That should be the bottom. Oops. Let's just do that. And let's do... We're almost there. We just have one more left. We've got the front, the back, the top, the bottom, the left. And we just need the right. So let's just duplicate that. So this will be right, and it will be index 5, and let's go back to GIMP here and Control Z, and then, okay, so right is going to be, great, another one I have to do backwards. So it's going to be this. No, that's not good. Let's do this. Yeah, it looks a little better. Okay. So this is, we're seeing the back side of this image, right? We have our cube once again that looks like that. And we, in GIMP, are looking at the back side of this right image. So I have to do it backwards again in my head here. So we're starting with this bottom corner, going here, here, here. Bottom here, there, 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 right? And Z is, all the Z's are negative. Z, negative, negative, negative. Okay. And then, oh, I didn't do that. There we go. I like lining everything up nicely. All right, so we're starting here. All the Z's are negative. So we have positive X. We're on the positive X and the negative Y. So X is positive. Y is negative. I hope I didn't start switching these up at some point in my head. I feel like I'm a little dyslexic, so that keeping track of this, I don't know. We'll see. We'll see how it ends up. The first two looked good. We actually tested those two, and they looked good. But we'll see where we get here. All right, so we got that. We got another one here that is negative x, and our y should still be the same, negative y. Then we go up to positive y. Our x is still negative. Then we go back to, right, ooh, let me make sure I did that right. So we went here, here. Third point is negative x, positive y. Y is up here. And yes. And we're going here now. So we are going to positive x, positive y. Yes. Okay. Great. Think we've got it. So now to hopefully test. Oh, let's. Okay. That actually ended up being not as bad as I kind of thought. I thought it was going to take me a lot longer. All right, so I'm going to get rid of all these bad ones. These are all the bad points. And we need to, I'm trying to think if I want to test all of these, if I want to export all of the images, all 6 images individually and just test them all first. Or if I want to try to make it all work and loop over all of these and generate all 6 at once first. Well, first I'm going to use the bathroom. So we'll be right back in a minute here, second here. All right, I am back. Yes, I did wash my hands after using the bathroom. Don't worry, don't worry. So I think I want to test them all individually right now. Exporting each image of our Skybox individually, right? So we'll just go down the line here. We'll generate the front one, the back one, the top one, the bottom one, the left one, the right one, right? And then I'll just make sure that it works in our little previewer here. Because if it works, the previewer, if everything, where did I, okay. If everything works here, then in our preview, then we, then we'll know that we're good. And then we can work on just cleaning everything up and making it all, export all the images all at once. And then we can start actually messing around with maybe some other kinds of colors or different things, maybe some kind of gradients, or maybe making like a little like horizon kind of thing. That'd be pretty cool, I think. We'll see. I don't know how I'm going to do that, but we'll get to it when we get to it. So let's just go right down the line. I'm just going to run the code, compile and run. Okay, so we just did the front. So what I need to do then is let's see. Oops. Can't find my folder here. There we go. All right, so this is the this is the folder where all of our images are currently. But I am going to just rename these because right now they're all the code just has front like hard coded in there, so it's just making all the files be front. But that's okay for right now as we're testing. So we're going to replace the file. Yeah, there we go. So now you can actually see what I had before. I had this file here. We're doing the same colors. Oh, actually, we might not be. But you can see these two are identical, right? So but I'll slowly be replacing all these other ones here. Not slowly. We'll be cranking here. All right, so that was 0. That was the front. And we are going to do the back. Whoops. Build. And then here. So we just call this one BA for back. Copy that here. Replace the file in this destination. There we go. Yeah, that matches that one. Oh, and then it's flipped. So you can see we did fix that Y issue, the Y issue we were having where everything was going upside down. I hope. Yeah, I think we did it right. Well, we'll find out. That's what we're doing right now. So we got, that was the back one. Now we got the top. So let's build, let's run. And what is this one now? Oh, top. T. I can delete this. Replace. And then that was top. Now we need bottom. Whoops, I'm hitting the wrong keys. I have to get used to switching down to my console all the time, doing C stuff, C++ stuff. All right, so we just generated a new one. That was the bottom one. So this is going to be bo.bm. Whoop. Replace. Okay. Yeah, the green just flipped on that one. And then all we've got is left and right now. Build that main. So this was L.bmp. There we go. And then we've got, oops, we've got right. Oh, getting ahead of myself here. There we go. R.bmp. We got this. R.bmp, blah, 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 blah. They all look different. That's good. So we'll see if we got it right. I actually do need to modify the JavaScript now. for the previewer. Because I believe, so here is where it's loading in all the image files, the BMPs. And I believe this order, I can set this now to be the same index order that we have according to Wikipedia. Oops. So let's do, what do we have for 0? Front is 0. So we're going to do F as 0. 1 is back. Yes. So that is BA for back. 2 is top. So that one is already right. Top and bottom. I actually already had those ones correct. And then we've got left. What, left is first, right? Left was phase 4, and then right was phase 5. Left, right, yes. So then left and right. Cool. So let's refresh our browser here and see what happens. Nice. It worked. Cool. Yeah, no issues there. Everything lines up correctly. And yeah, we're getting like perspective correctedness, looks like. All right, so now next step will be, well, first I'm going to grab my sweatshirt. Getting a little chilly down in the basement here this morning. All right, so now that we know we are generating all the sides and everything correctly, we need to do, and everything was left-handed coordinate system, I think, and I believe 3JS uses left-handed coordinate system, and that's why it worked, because I was reading yesterday a little caveat about, whoa, it looks like a seam. That's just OBS. I don't know what it looks like on stream. I guess I'll look. That looks like a seam running right down the middle there on OBS, but I'm blaming OBS because on my screen it looks perfect. And for some reason OBS it looks like way more blue here, but on here, oh, you know what? It's just my monitor. My one monitor here is bad. Yeah. Yeah. So I was gonna say, it looks like there's like a little seam from like the textures or something. Well, I don't know about a seam, but my monitor, I've got a BenQ like gaming monitor, and it's getting pretty old now. It's reaching like 7 years. It's like 7 years old now, I think. And it renders blue, or not, I shouldn't say render, but the blue pixels will just look weird when you've got like solid blues, like they just do weird things. So I think that's what I'm seeing. It looks way more blue here than on here, but here it's just like this nice like washed out blue look. So anyway, stuff's looking pretty good here. Let's actually let's make it so we can generate all 6 images in one run. So I can just run the program once, all 6 image files get generated, and then I can do some changes and then preview them really quickly, just because I'll copy paste all the images over. Yes, let's do that. And actually, I'm going to use like nicer names here. So I'm going to make that front, back, top, bottom, left, right. Wikipedia used something different though. What did it use? What did it use for top and bottom? Or is it up and down? It's like, I'll just keep it at top and bottom for right now. All right. Cool. JavaScript. I don't want to look at JavaScript right now. There we go. So what we need an array. So right now this is kind of like our plane thing here. A plane. Our four vertices that make up our plane, right? The four corners of the plane. So what I want is an array of arrays. An array of all of our individual arrays. So I can kind of keep the this format for each of them. So let's do, if I want to do it vec3, I guess I'll just call this planes. Vec3 planes equals an array of 6 planes. Oops. And then each one of those elements is going to be a, is that how you do an array of arrays in C? Somebody's got to help me here if somebody's listening. So if I do, oops, vec3, oh, yeah, how do I do, oh, yeah, I just do this, right? An anonymous vec3 array 4, can I do that? Vec3 type name is not allowed. All right. Oh. Oh, I just would do planes 6 and 4, right? And then we do C array of structs. We're learning. That's what we're doing here. Array of arrays of structures, hitting up the old Stack Overflow here. That's not what I want. Array of structures. I already have an array of structures. I know how to do that. Oh, now I'm getting into the AOS SOA stuff when I Google that specific thing. We're going to try something else out here. Help chat if somebody's there. If I'm doing an array of structs, so I have a vec3 struct, and I'm doing an array of, so I'm going to do 6 arrays of 4 arrays of vec3s. An array of 6 arrays. 6 arrays of 4 vec3s. That's the correct way I said it. All right, if nobody's there, I'm going to give it a shot. Yeah, because here I could just do anonymous, my anonymous vec3s. Right? Maybe that's only the C++ thing. Maybe in C that doesn't count. If I do, so if I do vec3 planes 6, 4, and then we do, then I guess we would have an array of arrays like this, right? So then this would be vec3, right? And then let's copy this. No errors. Okay. That looks like it. So this is front. Cool. And this would be back. Whoops. Oh boy. Front, back. Front, back. Let me just do all these. What do we do? Top. Oh, and I like putting, well, I guess I don't need to put the index now anymore. Yeah, I'll do it anyway. Front 0, back is 1, top is 2. Let's see, we've got top 2, bottom is 3. Oh, 3. Left is 4. And right is 5. Cool. So what did I get so far? Front, back. We need to copy the top. Wow. VS Code is not getting my indentations here. It's kind of annoying. VS Code's C and C++ support is not the best so far. Like it's okay, but like IntelliSense is really slow, and like versus like JavaScript or something, it's really fast compared to. Well, there isn't really IntelliSense with JavaScript. It's all dumb. Okay, we are looking good. Bottom 3. And, oh, I'm going to delete all these anyway. Oh. Left 4. And right 5. Beautiful. All right, so we're looking pretty good here, I think. Let's get rid of, well, we can get rid of this whole single face thing. Let's go. Yeah, let's just get rid of all of this. And that way we'll get our errors down below and we'll know we need to fix. All right, so the way it works right now is actually I loop for every pixel position once. So we are like, you know, if I have a, we'll just do a 4x4 here. So we're trying to we're first finding our position of our pixel in 3D space, right? So we have this cube. We have this cube of 6 images, right? Or, you know, 6, what will be 6 images. And the first thing we do is we only once actually loop over each pixel. And then each position there, then for each plane, will then get generated in the correct, will get put into the correct position. So, like if we've got our outer loop, which is right here, it's or we have 2 loops, and then we're gonna have another loop inside of that. We're just looping for each pixel position. So I'm doing, you know, we're starting down here now. But we're going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? But in our case here, we're doing a 256 by 256 pixel image. But for sake of example, since I'm not going to draw 256, a grid of 256, we're just looping basically this way, right? So our outer Y loop here, our outer loop is looping in the Y, so it's looping this way. And then our inner loop here is looping along the X, right? So we do an X loop for every row, right? Cool. And at this point here, we're calculating that pixel position in 3D space. So what we want, so like here is where I have the error now. Identifier front is undefined because we deleted that. So we're going to do another loop inside of this. That's going to be a loop over our 6 planes. And then wherever it says front here, that'll just be that'll just be planes. And then the correct index, this first index. And then these indices are hard-coded, right? So I have 1 and 3, 0, 0, 0, because those don't really change. Those relative to each other are important. So all we really need to do is just another loop. Int, we'll do I guess. I is less than, I guess I need to put, I'll do some variables here. Int num planes, 6. Should be a constant, I guess. And then this is 4. I don't really need to change that. Oh, yeah, it does. Okay. Because we're always doing a cube in this case. It's always going to be a 6, cube's always 6 sides, right? That's good. So then we now loop for whatever num planes is. Oops, I++. And then now all of this code, and I'm going to get rid of this commented out stuff. I don't want it anymore. Oh, pix index increments. Okay, that only increments. Oh, yeah, we need to set up more images now. That's right. So, because right now it's only generating one, it's doing one face and just generating one image struct for that one face, right? But now we're doing 6. We've got the faces, we got the planes. I'm going to rename this to face, num faces. No, we're going to keep planes. Okay, so yeah, here we're just doing one image, right? So this needs to be changed to we will do image, okay. All right, so let's do we do image array, an array of images, which is going to be num planes, and then each one of those is going to be an image, and I can do it this way, right? Oops. Oops. Can I do it this way? Maybe that's a C. Maybe that's a C plus. Oh, that worked. Okay. So it does work that way. So that's just going to be 3. Okay, and let's just put this in one thing. So we will say int img width equals something, int img height equals something, right? Or so we can plug 256 in here, but just so we can change this variable in one place. And then this will all be img width, and this will all be img height. There we go. Multi-cursor and everything. Got it. Cool. And then we'll loop over each of those and malloc each pixel array. So for num planes. Actually, we could just do that in... We don't need to do that right away. We could just do that since we're looping here over num planes. Yeah, let's do that. So oops. So we've got images, and we're going to make that and image width, image height. Yeah, these are our. Oops, let's do that. All right, so we're looping for each plane, and now we're allocating the memory for each plane. So our array of pixels, that's the memory that we are allocating. We're doing that for each plane as we go. And then, yes, so that should set us up correctly. Now for, yeah, we need to fix where we're using front here. So this is no longer going to be front, it's going to be planes. And then planes. And then this will be I. And then that index of that inner array. So these will all be planes I. Planes I, planes I, planes I, and planes I. Okay. That's looking pretty good, I think. Oh. That's not good. Oh, this isn't good either. Yeah, we need to just change that. Yeah, image width. Because there's... Oh, first is height. First is height. And then image width. And we're setting up all of those. Yeah, we're setting up all of those images. The array of images here. 2, 3, 4, 5. We need a sixth one here. How did I end up with only 5? Yeah, there we go. We got 6 now. All right. And img. This needs to be imgs I. Pixels, pixindex, p. That's looking pretty good. All right. So in theory, our loop should be all good, generating all the positions and everything. The one thing we need to do here now is actually write error type img. Yeah. Why isn't that highlighted? VS Code, I'm telling you. It's not working with C and C++ very nicely. So now we're going to just do a loop over imgs. Or I guess maybe we could just do it in this loop, right? Yeah, we might as well just do it here. I don't think there should be anything wrong with that. Oh, no, sorry. We can't do that because we're looping over every pixel. Then we're looping over every plane for each pixel. Kind of backwards of what it would seem like it should be. But I actually think this ends up being less work. Because this work needs to be done anyway. And otherwise, you end up just doing the pixel division. If you do it this way and then but loop over every pixel for every plane, then you're doing all the division for all the pixels 6 times instead of just doing it once. Okay, so I guess we're going to need to do I guess we will just do all of these individually. So we'll write each, or this will be address of imgs 0. Yeah, let's do oops. Okay, so this will be img 0, 1, 2, 3, 4, and 5. And then we will be doing 0 is front, 1 is, oops, I hit the wrong key there. I hit end. Okay, so 0 is front, 1 is back. Front, back, top, bottom, left, right. Front, back, top, bottom. Front, back, top, bottom, left, and right. Okay. All right, we'll see how that works. Now we got some errors here. Img undeclared identifier. Yeah, I'm using img somewhere still. Main CPP 73. Oh, yes. So this should now be img width, and this should be img height. Yeah, because VS Code is not showing us our underlined errors here. Img vec3 scale, no overload function takes one. No overloaded function takes one arguments. Vec3 scale, that's at line 74 here. Oh. Yeah, that should be fixed now. There we go. And build main.exe, run it. I guess it didn't work. Oh, it did work. Did it seriously take a long time to do that? No, that's weird. All right, we got some weird problem here that it's taking that long to generate. Okay, well let's look at actually what the images look like, because maybe I screwed it up royally. Oh yeah, we got something wrong here. If we go, yeah, back, bottom. That's interesting. All right, so let's let's see what we're doing here. And I bet you I did something kind of dumb with, oh, no, wait a minute here. Let's see. So for each pixel, we're then looping for each plane. We should be doing all of that correctly. Vec3, do we... Oh, I made a terrible mistake. Okay. Yeah, that's really bad. All right, so I was thinking, oh yeah, we do the malloc for every plane, but we malloced 256 squared arrays of 256 pixels. Yay, okay. That's bad. The malloc was running for every pixel, for every plane. Yeah, and that's why we ended up with garbage pixels. Yeah. Gotta love that. Okay, so we set up our images, and now we need to do for int I equals 0, I is less than num planes, whoops, I plus plus. So in here, we do just our 6 mallocs rather than a million. And then probably be like some smart optimization thing to like malloc all 6 in one thing and then offset each of those. That'd be kind of cool. That'd be cool to mess with. So instead of doing 6 mallocs, we just do 1 malloc. But we'll leave it this way for now. Build.bat. Yeah, there it was really fast. Exactly as we expected. And here, yes, we're looking good. So There's our images. They look correct now. Cool. So now let's try. So let me copy and paste all of these. Actually, let's do a new thing here. Output, image output. We'll just say output. And we're going to dump all of the files in there. So then we do build.bat, build main.exe, and then we should have now a folder in here that's output with all of our images. Perfect. So let's delete all these. BMP, 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 BMP. We'll just do that first. So we got output, and then we can go to, go to scripts folder here, and then this stuff should be matching up. Front, back. I changed the names. Dump them in here. Oh yeah, and it didn't delete any of the old ones. Let's delete the old ones. F, L, T, R. Actually, I'll keep them. No, actually, I'm not going to keep them because I can see that they all matched. So now if we go back to our browser, rerun this, boom. Yes, everything's looking pretty good. Cool. I like it. And we're generating all 6 at once there, which is nice. All right, and I don't remember what I wanted to do now after this. But now that that's working, let's try, well, I'd like to mess around with the colors a little bit and try some different kinds of things to see how they look. At this point, it's a little more of like a creative kind of thing rather than proving that all of this is working. And actually, too, what's happening is these are just 256 by 256 images, but the texture filtering and everything in here ends up looking relatively good, I guess, maybe. And we're probably running into more issues. There's like some banding there, but that's probably more of a rendering thing rather than actually like a pixel resolution thing. Cool. Let's do, I did want to take a look at what it would look like if I were to disable the I wanted to disable the part that's actually mapping it to like the sphere, doing kind of the spherical mapping, right? So our loop here, this is kind of the more magic sauce kind of thing. Not magic sauce because it's very simple, but the loop here is where we're actually generating all of those color values, right? So our outer loop here is for the Y pixels, the pixels going up, right? Or you could say for every row of pixels. And then our loop here is going along X, is going along every pixel along the X, right? So at first we're doing that row 0, all the pixels along row 0, then we go up to row 1, right? And our new loop we just added is for each plane, right? So we're first looping for every pixel position, but we're doing that for every plane. Ooh, actually that reminds me we should do, we need to put these variables up here. We need to do float expose equals x over img width. And then we do the same thing, but this will be y pose, and this is y over img height. Okay, so that will replace what we're doing here. I think we need to cast this to float to actually get a float out. Otherwise, these would just be ints, right? Yeah, it would try to do the division and just be 0 or whatever. Okay, so then in here, we can do expose. Yeah, because these values here change for every pixel position. I guess maybe I should change this to like pix. Well, yeah, so what's going on here is we loop for every pixel. Then we are figuring out a floating point value. So our two loops here establish us to loop over every pixel in our image, right? And in the example here, I'm just doing a 256 by 256 image, right? So we're looping from pixel 0 all the way to 256 squared, whatever pixel that is. And we have what we're doing is figuring out like what percentage that pixel would fall into the width and the height, right? So that's what this x pose and y pose is. And maybe I should rename these to be x percentage. Because basically we're taking whatever pixel value that is. I was using this example in GIMP here, right? So we're looping for every pixel. We're starting from the bottom technically here and then going up like this. What we're doing is taking the x and y value of that pixel. So here would be 0, 0 for this one. And then here would be 1, 0, 2, 0, 3, 0, 0, 1, 1, 1, right? So we're taking those and dividing those, whatever pixel value we have, x, the x value, dividing it by the width of the image. We're taking the y value, or the x value, dividing it by the width of the image. The y value, dividing it by the height of the image. So that's telling us like what relative like percentage we are. You know, so if we take pixel 0 and divide that by 4, because our image width is 4 here in this example, then we get 0, right? If we take 1 and divide that by 4, then we get 0.25, right? So this pixel is 0, it's like 0% of the way through the image, right? This represents like 0, here would be 0.25, here would be 0.7 or 0.5. We're halfway through the image. You can think of we're right on that halfway line with this pixel. And we're halfway through the image there. So 2 divided by 4 is 0.5. And then here we do 3 divided by 0.4 gives us 0.75. So we can think about that line there being our 0.75 of the way through. So here it's 0, we're 25%, 50%, 75%, right? And we never reach 100%. Because the next, basically the other image of the wall is going to be that 100% kind of, so to say. So that's where we're generating those percentages of how far we're along, right? And obviously in this example, I'm just doing a 4x4 pixel thing, but it's a 256 pixel thing, right? Or currently, but I'm probably going to step it up to, 1024. We always have to do a power of 2 for the 3D renderer. An image that has a width of the power of 2 and a height of the power of 2, and they need to be squares, right? So the same width and height are equal. So yeah, so that gives us, images of 4, 8, 16, 32, 256, 512, whatever, 1024. So basically then we're looping along every single pixel of a 256 by 256 image, and we're dividing each pixel by 256, right? 0 over 256 is 0. 1 over 256 is some really small number. And we're getting those floats, we're getting those floating point values out of that, right? And then, so we know all of those like percentages, right? That's kind of what we're going for, is where along the image we are percentage-wise, pretending that the width is a number from 0 to 1 and the height is a number from 0 to 1, basically. So we're figuring out those percentages. We're storing them here, right? So for every pixel, we're calculating that. And actually, let me make sure that everything works after I said that. Here. Yes, okay. So everything's still good after I moved that. So then what we're doing from there is we are taking the plane, the position of each plane, right? Because this next loop, this next for loop here is for each plane we have. So we're doing 6 planes, we're doing 6 sides of a cube, right? So we're starting with index 0. Here's our array of our planes, right, that we did before. So these are each plane, and each plane is just simply its 4 vertices, an array of its 4 vertices, right? So the corner 1, 2, 3, 4, right, of each plane, right, of each square. So what we are doing is figuring out, I got to remind myself exactly what this is. So we are taking each point of the vector, each point of the plane, and subtracting. So we're taking, we're orientating that each vector here back to 0, right? So we're saying take this plane, so we're taking this point 1 of this plane. So we take point 1 here. This is point 0, point 1, point 2, point 3. We're taking point 1, subtracting point 0 from that, right? So we're basically orienting this point with orienting it with the 0, 0, 0 pixel position, right? So that's this first not pixel position, but our 0, 0, 0 position in space, which is the dead center of our cube, right? So then we subtract this point from this point, and we created 2 new vec3s just for that. And then, you know what? I could probably declare these up elsewhere, so these aren't getting declared every time in the loop. So we're subtracting that, figuring out the position of each point. Well, not each point. We're taking this one. We're doing point 1 minus point 0, and we're doing point 3 minus point 0. And then we are scaling that to our x and y positions that we've calculated that we had before, right? We're scaling the x coordinate and the y coordinate to that. And then we actually then we create this new vec3 that's going to be our pixel position. So we add our orig X and orig Y vec3s, which have now been scaled to the correct position. And each of these individually, I would need to kind of take this apart to show exactly what's going on here. But we add those into just one vector. We basically are combining these two vectors into one now, is what's kind of happening here. Then we reorientate ourselves back with the 0 position here, right? So we reorient ourselves back with like that. And now we have our pixel position of that pixel in 3D space, of that pixel of that face, right? So if we're halfway along, our front plane or whatever, or what, front, up, down, whatever, we have that pixel position from 0, 0, 0. So then what we do is we scale it back down to, because we take whatever the length is of that, kind of like I was explaining here before, like let's say we're looking top down. We're looking at the front. This could be the front image and then the left image. We're looking top down at them. So like the very far corner position in this just 2D example, is here's our camera oriented at 0, 0, right? In this 2D example. But it basically just applies itself naturally up to 3D as well. So in this case here, we want everything to look like it's a distance of 1 away, right? Because the image in this example at its closest is 1 away, right? Direct head on is 1 unit away. But we want this pixel, the pixel way out here is square root of 2 away. So it's 1.4 or something away, 1.414 or something like that. So what we're doing is simply taking we find the distance of the pixel from 0, 0, or, in our case, we're doing 0, 0, 0, we're doing 3D. And then we are dividing 1 by that number. So we're doing, we're calculating the distance as our vec3 distance function between our origin, which is 0, 0, 0, that's just 0, 0, 0, and our pixel position. So that gives us whatever that distance is. And in our example, we were showing that, maybe it was the distance of square root of 2, at least at its furthest away. That's what it would be. So then we're simply dividing 1.0 by that. And then we are scaling. I don't know why I have this in a separate variable now. We don't really need that. Let's clean that up. So we are scaling the pixel value up. So then we're finding that the pixel position, that would be here, right? So we're finding that new pixel position as if it were to be mapped onto the sphere. So then basically what we can do is do any colors and whatever that we want, but we're doing it based upon pretending that this pixel is actually here. So like all these pixels would be all actually think they're mapped along the side of a sphere, right? Or, in our 2D case, just a circle, right? So all these pixel positions would be pretending like they are mapped along the inside. They'd be interacting with the rest of the 3D world as if they were mapped along the side of a sphere. But really, that's just getting projected back onto this flat pixel image, right? Onto just this pixel image. So we're getting that correct perspective and everything just baked right onto our flat 2D image, which is pretty nice. So there should be all sorts of other things we could do. We could do all kinds of different like color kinds of things, and they should all end up getting mapped correctly back to our 2D image. Sorry, it's kind of hard to explain. Ugh. And I kind of forgot exactly all this stuff that I had going here, exactly why the math worked that way. So I'll have to refresh myself. So my goal again with this is maybe make like a little YouTube video or something explaining kind of how I did this and everything. So gotta make sure I understand what I'm doing. I'm gonna hit the bathroom quick, and then we'll be back. All right, I am back. So, first thing, get my speakers back on here first. Sorry, spamming that Windows audio stuff. So what I want to do first is actually just get rid of the perspective thing, just to show that all our colors and everything, just kind of everything all falls apart when we get rid of that. So all we need to do is just comment out this line that scales our pixel vector to the correct position along the sphere. So now we're no longer correcting that pixel. We're no longer kind of projecting it into onto the sphere. We're just going to leave it at its actual like flat image. And now this is going to look, what I'm thinking it's going to look like is it's just going to be all solid colors now. There'll be a little bit of blend, but no nice faded blend. It's just going to be like a bad looking cube of colors. Oh, not really paying attention. I probably didn't compile. I probably just ran the exe. What? Did I not build main? What is going on here? Let's see what's going on. Why? GeForce Game Ready driver is available. All right. All right. Why does this not look... Let's delete these. Oops. What? Oh. Actually, I think I can tell. Oh, I didn't think about this. They are... Okay, so what I thought was that they'd be all smashed. The color values would be all smashed, but that doesn't make sense because we're dealing with three different color. The colors should still get nicely faded like that, but we're losing, if you can tell, we're losing our nice curve that we had. Now these are like just flat lines. So if we looked at this projected, we would just see like the hard, we should see like hard edges. Let me just make sure I'm not crazy. And uncomment this line. We are going to build, and then before we run, so if we look at this directory, because I guess these Windows will update these really quickly. Whoops. So when we run the program, we should see like these lines all of a sudden will like curve. Like the green here will like curve slightly rather than being like a straight gradient there. So we run. Yes. Okay. And they all got a little less intense too, because now they're kind of further away from those color things. The way I'm doing the color is weird. It doesn't really make much sense. It's more of just a way to kind of test everything. Because it doesn't really make a whole lot of sense from like a real 3D world perspective. But that being said, we generated all the new ones. Let's copy them. Oh, now we need to go back. We need to comment this line out. Generate these colors. Yes. And then let's copy them all to this directory here. And then in here, we refresh. Yes, okay. Yeah, so it's not super obvious, but you should be able to see that we've got, you know, some corners. We can see the corners of the skybox and everything. So that is as we would have expected. It actually, in my head, I was thinking it would be a lot worse than it is. But it's not too bad. But yeah, so we are proving that it is working with our one little nice one-liner there, projecting everything back onto our sphere. Nice. So I'm trying to think about what else I kind of want to do with this. And I might actually just switch back over to working on my JavaScript game. Actually, what I think I'm going to do, I'm going to kill the stream here. Well, I'm going to think, yeah, obviously this is bad, but we fix that now. I'm going to kill the stream here. We are going to, I'm going to think about what else I want to do to kind of extend our Skybox stuff now, make it cooler, more interesting, maybe some kind of horizon line kind of stuff and everything. So I'm going to, because I'm not really, I mean, now that we got all this working nicely with the new planes and everything, and it's just copy paste into our preview. Now that we have that, I feel like I'm good for now on it. So I'm going to think about the other stuff I want to add, and then we'll probably come back to this in another stream. But for now, I think I'm going to kill the stream, and I'm going to take a little lunch break. Then I'll come back in a bit, and we'll be jumping back into my JavaScript game. But yeah, I think that's it for now. We'll see you back here after lunch. And we'll be doing some JavaScript. So, ta-ta for now.